Today, I'm very excited to tell you about new constraints on the spin of the supermassive black hole in M87, also known as M87 star. So the fundamental parameter of the Kerr metric has two parameters, as we know, the mass and the spin. And we know that the M87's mass has been very well measured. We know that it is about 6 billion solar masses with a 10% uncertainty from both the measurement using the black hole shadow with the Event Horizon Telescope and also using stellar dynamics. But what about the spin, the second fundamental parameter of the metric for spinning black holes? And in this work, we were able to constrain the spin of M87 star using measurements of the jet power and the mass accretion rate. So we used the average jet power that was obtained from measurements of based on Chandra observations of X-ray cavities that were inflated by the jets from M87 over time. So this is actually an average jet power using these bubbles as calorimeters. And we also were able to estimate the mass accretion rate onto the black hole from Faraday rotation measures, assuming that the relatively inefficient accretion flow acts as the Faraday screen. And finally, we have assumed that the jet is Blandford-Znajek powered. In other words, that the jet is taking its power from the spin energy. And we have used models based on general relativistic magnetohydrodynamic simulations. So this plot here, it shows on the y-axis the efficiency of conversion of rest mass energy associated with the accreted mass into jet power as a function of the black hole spin for both same models with a low value of the magnetic flux and MAD models with high values of the magnetic flux. And the main result of this work is that we have obtained constraints on the black hole spin and the magnetic flux of M87 by combining this jet power and accretion rate measurements with a sound GRMHD model for the jet powering. And the whole story is summarized in this plot. In this plot here, the y-axis is the magnetic flux. The x-axis corresponds to the power law index regulating the radial variation of the density in the accretion flow, which is one of the main uncertainties in this work. And so the bottom line is that we find a minimal value for the spin of 0.4 if the black hole is prograde. And we have ruled out a variety of sane models because the magnetic flux can't be smaller than 5. And I hope that these constraints on the black hole spin and the magnetic flux will be useful to the community in the future. Thank you.